Hi guys, this is teacher David. Today I would like to go on to explain further on the applications of differentiation, specifically in the area of maximization and minimization problems. And what I would be explaining now would be useful for students who are reading their O-levels, A-Max, and also in those in IP year 4 for their max subjects. So without further ado, let me go straight to the one of the questions that I have. Okay, a cylindrical can is designed to have a capacity of 800 cm cube. Find the dimensions of the can that will minimize the cost of the metal used to produce the can. Okay. Okay, one example you have is this. So you drink your Coca-Cola, right? Your Coke bottle. Okay, probably your Coke bottle doesn't hold, a can of Coke doesn't hold so much Coke in there, 800 cm cube. Probably a large can. Okay, usually what you see is a 500 cm cube, but let's say Coca-Cola, they want to produce an 800 cm cube. A can that's contain 800 cm cube of Coke in there. So before they actually produce the can, right, that contain 800 cm cube, they need to do some research and they need to do some calculation on the material that they need in order to produce a can, right, that can hold 800 cm cube of Coke in there. Okay, so that's the practical aspects of differentiation. So of course, from a business point of view, you want to minimize your cost of production. So to minimize the cost of production, you need to minimize the amount of metal you need to produce the can. Okay. So you know that a Coke, right? A can of Coke. Okay, that's my can of Coke. Okay. So you have your can of Coke and you have your R and you have your H. So your volume will be pi r square H, right? Agree, pi r square H is the volume, the capacity. So they said that capacity is 800, right? Okay, pi r square H is 800. Your H should be 800 over pi r square. That's your H. Then area, right? So total surface area. Total surface area will be 2 pi r square plus 2 pi r h. Okay, 2 pi r h, you find this part. You understand what I mean? 2 pi r h. 2 pi r h, you find this part. This part. Not the top and bottom, the surrounding.
Mm.
Okay, 2 pi r h. 2 pi r square is top and bottom. H is this guy, right?
Uh-huh.
Okay, this is your total surface area. I cancel, R cancel, yeah, 1600 over R. So this is the total surface area for the material you need,
Mm.
total surface area. Then let's call this A. A equal to 2 pi R square plus 1006 over R. And dimensions or can minimize the cost, right? So I need to find minimum A, minimum A. So to find minimum A, right, I differentiate A respect to R first. Okay, this is 4 pi R minus 1600 over R square. Agree on? When you differentiate, you'll get this.
Uh-huh.
Okay. Then second derivative. Second derivative. You differentiate one more time. Okay, this one is R negative 2, right? I bring down will be positive 3200 over R cube. Understand, no?
Okay.
You understand how I get this,
Yeah.
Negative bring down, negative 2 times negative 1600 is positive 3200. Then R negative 3, so it's R cube. Okay, second derivative, first derivative. Then I'm supposed to find minimum A, right?
Yeah.
Minimum A occurs when dA dr is 0. Because your
Uh-huh.
area won't change anymore. That is the minimum.
Okay.
Okay. So 4 pi R minus 1600 over R square is 0. So your 1600 over R square is 4 pi R. I bring the R square over, right? Or you can see it from another point of view. Okay, that's your R. For it to be minimum. Then you substitute this into here, right? Second derivative. Your second derivative would be positive. Okay, power 1/3, power 3 is power 1. Understand? No?
Yeah.
Power 1/3, power 3 is power 1. So I just write 400 over pi here. Okay, 8 pi plus 4 pi, 12 pi. So second derivative, right? Greater than 0, right? So when R is 400 over pi, power 1/3, right? Your A is a minimum. Okay, so your second derivative is greater than 0, A is minimum. When your R is 400 over pi, power 1/3.
Okay.
Okay, so find the dimensions of the can that would minimize the cost. So you just found R has to be this value. So the dimensions of the can will be R is this value. Then what's your H? H, you just sub it in. So once you get your R and H, that will be the dimension of the can, right? You agree?
Yeah.
Okay, that's your R. Your H, you just sub it in. Pi R square. R square. Okay, 2/3 lah. Pi R square. So this pi 2/3. Then this one will be 800 over. This is 3 over 3 minus pi 2/3, right? Divided by pi 2/3, right? So it's pi 1/3. 3 over 3, then this denominator, pi 2/3, right? So it's 1/3. 400 to power 2/3. So this one you can punch in calculator. Okay, you have 10.06. 10.06159. 10.1. So you have your height, you have your radius. Your radius, right? To be exact, 400 over pi power 1/3. Okay, your R is 5.03. So you have your dimensions of the can already. You got radius and height, means you got dimensions of the can already. Okay. This is how you do to minimize the cost of the metal. Because when R is 5.03 and your H is 10.1, right? Or 10.06, that's when the A is the smallest. The total surface area is the smallest. I understand.
Yeah.
That's how you minimize the cost. and yet still can produce can that can hold 800 ml of Coke. Okay.
Okay.
Okay. Then I have other question. Okay, another question is a piece of wire of length 480 cm is bent into the shape as shown in the diagram. Okay, express y in terms of x and express area enclosed by the wire which is your A in terms of x. Find the value of x and y for which A is the maximum. Hence, find maximum area. Okay. And the shape looks like this. The shape is going to look like this. Let me see. I think the shape looks like this. And here is y. Here is y. Here is 48x. Wait, okay, here is 36. Oh, express y in terms of x, right? You know what to do? You know what to do?
I think so.
480 basically is a parameter. Okay, 480 is a parameter. So the parameter is 8 plus 36, 44. 44 plus 8, 52. 52 plus 48, 100. Can you see there's 100x? You understand how I get this, huh?
Yeah.
Okay, 100x and 2y is 480 lor. So y in terms of x, right? Right, lor. Y in terms of x. Okay. Then okay, let's see. See, you can find this area. Okay, they'll let you know this 45 degrees. They'll let you know this 45 degrees. Then 45 degrees means isosceles triangle here, right? And now isosceles triangle, right? That means so this part plus this part, you get a square. You understand?
Okay.
So this square plus this rectangle, or rather this whole thing, this whole rectangle, okay, because it's the same, right? 48, 36. 48 minus 36 is 12. So here is 6x. Understand? And here is 6x. You understand how I get 6x?
Yeah.
6, 6, 12 lah. 12, 36, 48 lah. So 36 plus 6, 42. 42 times 6 lah. Understand? 42 times 6.
Okay.
So area, right? Area is 42 times 6. Okay, I get this piece because this piece shifted here. So it becomes this piece. And next is big piece of rectangle, right? 48xy. Okay, that's the area of this whole thing. So 42 times 6, 252x square. Your y is this guy, right? I sub it in. (48 times 240). 11520 minus 48 times 50. 2400 x squared. So area is 11520x minus 2148 square. So that's my area. Okay, express y in terms of x. Express area in terms of x. Done, huh? Then dA dx. Okay, this is part 2 now. Huh? dA dx. 2148 times 2. 4296. So this is my dA dx. Second derivative. Negative means maximum, right? When it's negative means A is maximum, right? Agree?
Yeah.
So I just sub this is 0. So dA dx is 0. So your 4296 x will then be 11520. Okay?
Okay.
Then x will be 11520 divided by 4296. X will be 2.68 something. 2.68, 156. That's my x. Then your y, sub it in. Y will be 240 minus 50x. One 105.92. So maximum area. Maximum area. 11520. Your x is 2.68, right? Minus 2148. 2.68. 156 square. Punching calculator. You have 15445.35 cm square. So that's the maximum area. So x and y when it's maximum. So this is to prove it's maximum. Therefore, A is maximum. Okay, when dA dx is 0. Okay, A is maximum. So that's why I equate this 0. Find my x. Find x, find y, find x, find A. Okay? Any question? Any question?
No.
Cool, huh?
Yeah.
If you're cool, right, I show you another example. Oh, understand, oh?
Yeah.
Pythagoras theorem, you get your distance KB. KB is how much he needs to roll.
Mm.
The distance he needs to roll. Then B to C, the distance is 500 minus X. And X is the distance, right? From A where he landed. So obviously you need to find X. Okay, you need to find X where T is minimum. You know T has to be minimum, right? As quickly as possible. As quickly as possible. That's how you know T has to be minimum.
Okay.
Okay. So this one, okay, let's rearrange this thing. Mm. Okay, 50 divided by 4. 500 divided by 40, you have 50 divided by 4, 25 over 2. 25 over 2. Okay, this is what you have, your T. Okay, dt dx, okay, half I bring down, agree, you agree or you disagree? X over 30, right? Okay, you're still there? Hello,
Yeah.
you're still there?
Okay.
You understand, all? Okay. Okay, dt dx. Okay, how far should A be? So dt dx is 0. So
Okay.
dt dx is 0. Because T minimum means dt dx is 0. So you have X over 30 multiplied by 400 plus x squared equal to 1 over 40. I bring it over to the other side, equal 0, then I bring over to the other side. So 40x equal to, cross multiply, then I divide by 30. Okay, everything times 9. Agree all?
Yeah.
Everything times 9, then I bring over. So 9 minus 16 minus 7. Agree? This one I bring over. This one bring over. 16 minus 9 is 7. 7 equal to 3600. X squared x would be square root. You have 22.67. Okay, this is your x. So this is how far A should be. Then how do I know this is the minimum?
Uh-huh.
You use first derivative test to justify. You use first derivative test.
Okay.
First derivative test. Okay, x is how many? When it's 0, x is this guy. Yeah, x is this guy. Okay, 3600 over 7. So minimum will be 22, then maximum 23. Then you put in the value, find your dt dx. This is 0. Then when x dt dx is this guy here, right? When x is 22, right? When x is 22, what's the value? Okay, you have negative something, negative 3.3 something. Negative 3.3 times 10 power negative 4. Okay, let's say it's 23, right? You have positive 1.53. So this is negative, this is positive. Negative, positive. So this is the outline. Outline. Sketch of tangent. Okay, this is sketch of tangent. And this outline of graph. Okay, outline of graph will be like that. Yeah, you understand what's going on, no?
Yeah.
So like that is minimum. So that's how you confirm it's minimum t. When x is this, that's the minimum t. This first derivative test to test that it's really minimum.
Okay.
Understand, no?
Okay.
Any more question? For this question, you'll notice, right? It's easier to use first derivative test than second derivative test.
Okay.
Because this expression here, right, is not easy to differentiate. Okay? You notice this expression not
Okay.
easy to differentiate?
Yeah.
Yeah, that's why you use first derivative test. So far, any question?
No.
No. Okay, then you can continue to do the question in the book. You do practice now 13.
Okay.
Okay. Hi guys, if you enjoy my videos and if you like learning about Amex in my videos, do click on the subscribe button right here below and you would receive notifications whenever I upload the new videos. So I hope to see you in my YouTube channel and thanks for watching my video. So all the best for students who are taking their O-levels Amex exams. Thank you. Bye-bye.